morning, good afternoon, good evening, depending on the time and where you're watching from. In this video, we'll be looking at NECO Practical Chemistry 2025 Volumetric Analysis. This is a predicted question, and this will give you a guide on how to go about question number 1. The question says A is a solution containing 3.15 gram HX acid in 250 cm3, and B is a solution containing 5.50 gram of a mixture of Na2CO3 and NaNO3 in 500 cm3. Question number A, put A into the burette and titrate against 20.00 or 25.00 cm3 of B using methyl orange indicator. Repeat the experiment to obtain consistent readings. Tabulate your readings and calculate the average volume of the acid used. B. From your results and information provided, calculate I, the concentration of B in mole per dm cube, II, concentration of B in gram per dm cube, III, concentration of A in mole per dm cube, IV, relative molecular mass of HX, V, molar mass of X, VII, percentage by mass of X in HX, VIII, volume of carbon dioxide liberated at STP. Solution to this problem. For the purpose of this video, we'll be using the endpoint 25.9 cm3. 25.9 cm3. If you have 25.9 cm3, to make a complete table using this endpoint, first of all, write volume of pipettes used. Volume of pipettes used will be 25.00 cm3. Of course, there's no need for indicator, but if you put it, there is nothing wrong with the indicator used because they have mentioned it in the question. That told you using methyl orange indicator. Methyl orange. Now from here, you can put off your line and get your meter rule. You write burette reading. This volume should be here. Indicator used. Burette reading must be in cm3. The moment you put burette reading in cm3, there's no need putting the final volume here in cm3. Here you have your initial reading. Initial reading. And finally, we have volume of acid used. Okay. NECO would always prepare a table like this for you, starting with raw. They'll give you first titration. First titration. Second titration. And Okay. If a table like this is prepared for you, now initial reading, you refill this to 0.00. Then you have 27.10. For your rough reading, this is also 27.10. If you refill to 0.00 again, you will have 25.90. Here will be 25.90. To 0.00, you have 25.90 and 25.90 breakdown. And to 0.00, have 25 at 26.00. Can bring this down to 26.00. I'll have 25.80. Okay, yeah, 0.80. Now mean that average volume, that is the A, be solving. Volume of acid, average volume of acid used will now be equals to this 25.90 plus 25.80 plus 26.00, all divided by 3. If you calculate very well, you still have 25.90 cm3 as the average volume of acid used. Now this one, put A each table red and titrate against 20 or 25 cm3 of B using methyl orange. Repeat experiment obtained, tabulate your reading and calculate the average volume of the acid used. We have answered A. Then B. From your results and information provided, calculate concentration of B in mole per dm3. If you go back to the question, say B is a solution containing 5.050 gram of a mixture of this in 5 square meter. Then BI concentration of B in mole per dm3. Let's use the short form conc in mole per dm3 of B will now be equals to mass of B all over molar mass of B multiplied by 1000 cm3 of solution B all over volume of solution B. Yes, this formula could help us solve for the concentration of B in mole per dm3. Now, from the question, mass of B is given. For molar mass of B is not known. Let's calculate the molar mass of B. Molar mass of B, and our B is out of the mixture Na2CO3 reacted, and nanotrade remains as impurity. So we calculate the molar mass of sodium carbonate as 23 times 2 plus 12 plus 16 times 3. This could give us 46 plus 12 plus 48, which is equals to 106 gram per mole. 106 gram per mole. 106 gram per mole. It means that the concentration as count in mole per dm³ of B will now be equals to mass of B from the question is given to us at 5.50 all over molar mass of B, that is 106 calculated, multiplied by 1000 cm³ all over in 500, that is 500 cm³. If you punch your calculator very well, that is 5.50 divided by 106, then multiply by 2. That will give us 0.103. That is 5.50 divided by this 1000 by 500 is 2. Everything will give us 0.10, approximately, to create significant figure, 104 mole per dm³. Mole per dm³. That is question number I. Then II, concentration of B in gram per dm³. Concentration of B, the same B, in gram per dm³. Concentration of B in gram per dm³. Now, since we now know the concentration of B in mole per dm³ and we know the molar mass, we could calculate conc in gram per dm³ of B with a relationship conc in mole per dm³ of B multiplied by molar mass of B. Multiplied by molar mass of B. This could give us the conc in mole per dm³ of B is just calculated to be 0.104, and the molar mass of B is also calculated to be 106. If you multiply 0.104 times 106 will be equals to 11.024, approximately 11.00 gram per dm³. 11.00 gram per dm³. Question III, concentration of A in mole per dm³. Concentration of A in mole per dm³. Now, since you have known that is I, concentration of A in mole per dm3. And since you have known the concentration of B in mole per dm3, you could use a general formula. The first thing is to get your equation of reaction, since the general formula requires number of moles of the acid and that of the base. Equation of reaction will be Hx, which is the acid given in amperes, plus the constituent of the mixture that reacted is NaNO3, also in amperes. And when this, you could have NaX in amperes plus water in a liquid state, then plus CO2 gas. Sodium is 2 at the reactant side, balance it at the product side by putting 2. Hydrogen is 1, but sodium bring 2 here to balance by 2 hydrogen, 2 hydrogen. Sodium 2, sodium 2, carbon 2, carbon 1, carbon 1. Oxygen is 3. This is 1 plus 2 to give us 3, so the balance. So using Ca, Va all over Cb, Vb equals to Na all over Nb, meaning concentration of A in mole per dm cube multiplied by the volume of A in cm cube all over concentration of B in mole per dm cube multiplied by the volume of B in cm cube is equals to number of moles of what? A all over number of moles of what? B. The Ca is not given, multiplied by Va, which is our end point, and we obtain it from the table as 25.90. 25.90 all over our Cb has been calculated as 0.104 multiplied by Vb, that is the volume of pipette used, 25.00, is equals to number of moles of the acid from this stoichiometry of reaction and from the balanced chemical equation is 2. And Nb, number of moles of the base, is 1. Means that our Cb now is equals to 0.104 multiplied by 25.00, then times 2. Times 2 all over 25.90 times 1. If you punch your calculator very well, we have 0.104 times 25.00 times 2 all divided by 25.90. I give us 0.200, should equals to 0.200 mole per dm cube. 0.200 mole per dm cube. Then question IV. Calculate the relative molecular mass of Hs. Relative molecular mass of Hs. Sorry. Ca. Okay. Ca, that's the coefficient, 25.90. Okay. Now question IV, relative molecular mass of Hx. Relative molecular mass of Hx. Recall from the question that the mass of A is given. So you could find the concentration in gram per cm³ because it requires this for you to calculate the relative molecular mass. Conc in gram per cm³ of A is equals to mass of A multiplied by 1000 cm³ of solution A, all over volume of solution A. Then from the question, mass of solution A is given to us as 3.15 multiplied by 1000 cm³ all over. From the question, the volume of solution A is given as 250 cm³. 250 cm³. We engage our calculator. 1000 divided by 250 is 4. Then 3.15 times 4. That will give us 12.6, which is equals to 12.6 gram per cm³. There's no need putting zero, it's already in 3 significant figures. Now, this is not what you're told to calculate. Now, you're looking for the relative molecular mass of Hx. Recall that the relationship between relative molecular mass and the two concentrations will be equals to conc in gram per cm³ of A all over conc in mole per cm³ of A. Yes, and we have gotten conc in gram per cm³ of A to be 12.6 all over conc in mole per cm³ of A, which is what we got here as 0.200. If we engage a calculator, very well, we have 63 is equals to 63 gram, 63 relative molecular mass has no unit, it's a dimension, let's put it to 63. Is the correct answer. Then molar mass of X. Molar mass of X that is V. Question B. Molar mass of X. Recall that the acid Hx have the relative molecular mass of 63. Now this means that 1 plus X, that's for hydrogen, is equals to what? 63. making x the subject of the formula x is equals to 63 minus 1. This will give us 62. So the molar mass of x, molar mass, the unit is gram per mole. So the molar mass of the radical of the acid x is 62 gram per mole. 62 gram per mole. Now, percentage by mass of x in Hx, that is VII. Percentage by mass of x in Hx, which will be equals to x all over Hx multiplied by 100 over 1. And x now is gotten to be 60. The value of x now is 63. The value of x is 62 all over the entire Hx molar mass, which is getting as what? 63 multiplied by 100 over 1. You have 62 divided by 63 multiplied by 100. You have 98. 98.4% is the same thing as 98%. 98%. And finally, we have volume of carbon for oxide liberated at STP. Volume of carbon for oxide liberated at STP. To calculate the volume of carbon dioxide liberated at STP, you need to bring the balanced chemical equation where we have Hx2 in amperes plus Na2CO3 also in amperes, which reacted to be 2NaX in amperes plus water in a liquid state, then plus carbon dioxide in gaseous state, which we are sure that is balanced. 2 hydrogen, 2 hydrogen, 2x, 2x, sodium 2, sodium 2, carbon 1, carbon 1, oxygen 3, then oxygen 3. Okay. Now from this stoichiometry of reaction, now carbon dioxide comes from what? Na2CO3. So we're going to relate it with. So it means that 1 mole of Na2CO3 produces 1 mole of carbon dioxide, which is in volume equivalent to 22.4 dm cubes of CO2. Now when you go back to the equation, the mole concentration of carbon for Na2CO3 is calculated to be, go back to your, and give us the value of what? Cb. The Cb there is calculated. Recall it was calculated to be what? 0.104 mole of the same NaCO3 will now be equivalent to x dm cube CO2. If you engage your calculator very well, you cross multiply. This will give us that x times 1 will give us x, and x is equals to 0.104 multiplied by 22.4 as 0.104 multiplied by 22.4 equals to, now give us 2.32 is 2.33 equals to 2.33 d dan cube CO2. Therefore, 2.33 dm cube of carbon dioxide is liberated at STP during the reaction. Okay, like I said, they could also ask for the precautions observed to obtain consistent or concordant readings. You could know that you ensure you personalize it. Of course, you ensured that the burette is rinsed with the acid solution to avoid what remains of water used in washing it from diluting the acid, and many more. Same way, the pipette is also what rinsed with the volume of the base to ensure that the remains of water used in washing it does not dilute the solution. You also ensure that the white surface is that the conical flask is put on a white surface, just to avoid what overshooting your endpoints, and many other precautions and those procedures that you follow. I know you have learned a lot from this video, and I know this has helped you equip yourself with the right knowledge for A in your NECO 2025. Do comment as you watch, then follow Superstar School of Science for more of chemistry. Like we always say, that our utmost priority is your success in all your exams, as long as chemistry and all other field of sciences is concerned. You have a wonderful day. Give us your testimony at the end of the exam. We had you. Bye.